This video is sponsored by my course, the Unreal Engine C++ Survival course. Using my knowledge from working in the industry, we start from the basics and work our way up until we've created an online survival game with C++. We create vehicles, clothing, weapons, Steam matchmaking, and much more. Get lifetime access for $25 using the link in the description. Today I'm going to be talking about Unreal Engine networking, and if I do my job correctly, in 1 hour you should have an excellent understanding of how to do networking in Unreal Engine. And I'm going to go into C++ at the end. I'm going to keep things more conceptual at the start because it's important you know what's going on before you actually learn how to write the code. So, what are we even doing when we network a game? Well, really what we're doing at the core of it is we're just syncing a bunch of different games together. So here I've got 4 different players all playing the same game, but it's important to know that I'm playing the game, say, in New Zealand, someone else might be playing the game in Brazil, someone might be playing the game in Japan. We're all running different instances of the game, and the whole point of networking is to sync up the games and make them look like they're all the same game, so that we actually feel like we're playing together. If you want to follow along in this video, just go to Content Examples, click the Content Examples and download them for 4.24, and you should be able to follow along in the same way that I do in this video. I will also leave a link to the Network Compendium by Exe in the description. It is an excellent resource. It's literally 111 pages of just information about Unreal Engine networking. So you can get a lot of the finer, more granular detail from this. So I'll link that in the description as well. So there are 2 types of servers in Unreal Engine. You have a dedicated server and you have a listen server. A listen server is when one of the players in the game is the server. You can see in the top left corner that guy is the server. He's actually playing the game. A dedicated server is when the server is not someone playing the game. The server is just a standalone server that hosts the game, and everyone that connects to it is a client. There's no server actually playing the game. The next thing to touch on is that the server is the authority. He controls the rules of the game, and if he didn't control the rules of the game, it would make the game way easier to cheat in. So basically what happens is if a client wants to do something like shoot a weapon, he shoots the weapon, but then he tells the server, hey, I've shot my weapon. At which point the server goes, okay, let's see if you've actually shot someone, and if the server thinks you've hit the guy, then he will decide to deal damage to the guy. So the clients don't talk to each other, they talk to the server, and then the server will replicate all that back to the clients in the game. So if I want to shoot this guy over here, I shoot, I tell the server I've shot, the server might validate things, like he might check that I have enough ammo to actually do the shot, and then if the server decides that I've hit the guy, he'll deal the damage, and then he'll replicate that back to me. And that might mean that I see some blood particles appear, it might mean that I see the guy die, but the server is going to send information back to all the clients in the game. Just know that he is the true game. Now in an ideal world, right, we'd have the server here playing the game, and all we would do is the server would send his exact game world to all the clients in the game, and all the clients in the game would just display the server's game world exactly as the server sees it. But unfortunately, there is way too much information. You would need to send every, position of the players, what animations they're playing. That is just way too much information to be sending over the network. So with networking, the big challenge is replicating as little as possible to make the players feel like they're all playing in the same game without actually sending everything. So the most simple type of replication to wrap our heads around is actor replication. It's literally a checkbox, you check it, and now that actor is replicated, and I'll show you that in a second. But what it means is if the server spawns something in, all the clients will see it as well. So for example, imagine a rocket launcher. I shoot my rocket launcher and I tell the server, hey, I've shot a rocket. Now, if the rocket is not replicated, none of the players are going to see the rocket. If the rocket is replicated, all the players are going to see the rocket. So for this ghost here, replication is not turned on. When the server spawns this ghost in, none of the clients in the game see it. But by replicating it over here, all the clients can see this ghost because the server spawns it in, and because it's replicated, it will automatically show up for all of the clients in the game. And I want to show you how simple it is. Here's the blueprint for the ghost that doesn't replicate, and the only difference is this replicates checkbox here is not checked. On the replicates version, we have checked the checkbox, and that is literally all you need to do. So if you check that box, when this actor gets spawned in on the server, all the clients will automatically see it. So if you wanted a rocket to spawn in on the server and all the clients see it, all you need to do is make sure this box is checked, and that will happen. So as I explained at the start, the server's game is the true game, and the clients are sort of just copying off the server's game. And so let's have a look here at the server. The server is updating the health of these two ghosts. On the server, this works perfectly fine. You can see that the ghosts' health are slowly going down by 10 units, and both ghosts get updated. On the client though, the health is not going to work. It is not getting updated on the client. However, if we enable variable replication, now our health is updating perfectly. And so this is why I love Unreal Engine. Let me show you how easy this is to get this health variable to sync. Here's my variable for the health, and you can see this is the ghost that doesn't replicate. It is broken. The health value does not update. You can see that the replication value is set to none. All we have to do is click on the health variable and set it to be replicated. And now when the server changes this health value, all the clients in the game will also get that exact same health value, and the value will sync up perfectly. You'll notice the difference here in blueprints as well is that when we update the health, we take 10 health away, but you can see that there is not a little replication icon next to the health. So if you see these little dots next to a variable, it means that that variable is replicated. So when a server updates this value, all the clients in the game will see it. The server needs to be the one updating this value. The clients cannot update it. Remember, the flow of data is the server does the update, and then all the clients in the game will have that data replicated down to them. Now the whole point of networking is to keep all of the clients in sync with the server. So you would very rarely want to do something like this, but if you wanted to, you could have something look different on the server to on the client. And in Blueprints, all you have to do is use this node called has authority. Authority means that I'm the server, and remote means that I'm a client. I am a remote machine that is connecting to the server. And you can see here that on the remote machine, we just set the ghost to be a different value if we're not the server. And so that's how you would achieve that functionality if you wanted to do it. And again, coming back to the flow of data, we're going to be using this a lot because remember, if something is replicated, it is the server that needs to control it, and then that data will be replicated down to clients. The health, for example, we always update that on the server, and then the health value will be replicated automatically down to clients. So we would want to use this to make sure that we are the server before we do something like set a health value. The remote would not set the health value because when the server changes it, it's automatically going to be replicated back to the remote, the client. Okay, so let's talk about rep notify. Now on the left, the server is changing a value, and what the value does is it updates this traffic light here, and it does it by updating the material on the traffic light to get it to update. Now this is a replicated value, and the client is receiving that information, but the client's visual of the traffic light is not updating. Yes, it is receiving the data, but it's not updating the traffic light. So what a rep notify does is it's basically a way of saying when this value changes, run a function. And in this case, the function we're running is going to update the traffic light. So here's my traffic light. You can see this is the value. It's called streetlight scalar. This is the value that updates the traffic light. And it is replicated. So the information is being sent to the clients, but the clients just aren't updating their own version of this traffic light. So all we have to do is change the replication to be rep notify. What this will do is it'll give you a rep notify function. You can see this is it here, on rep streetlight scalar. This function will be called on the clients that are connected to the game every time this is updated. And the clients will then update the material. They're doing a bit of custom logic here to update the streetlight material. So now what's going to happen is on the server and all of the clients, this function will get called and the traffic light should now update. And if we have a look now, the server is going to update that streetlight scalar value, and when the client receives the new information, it then calls that onRep function, and now what happens is it can update the traffic light, and now the two games will stay in sync. So if you've made it this far, this is the core of how replication works in Unreal Engine. Variable replication and actor replication are the two big ones. But the last part of the sort of whole system is something called RPCs. You remember at the start of the video how I said if the client wants to shoot his gun, he needs to tell the server that he shot his gun. Well, how does he tell the server that he shot his gun? He uses a server RPC. The server can also communicate back with the client using something called a client RPC. So if the server decides, hey, you've hit that guy, he can then do a client RPC to make the client display a hit marker on their screen so they know they've hit someone. So the client and the server can communicate back and forth using these RPCs. There is also one last special type of RPC called a net multicast RPC. This is an RPC that you can only call from the server, and when you call it, it will happen on all the clients that are connected to the game. So if you wanted to make an explosion go off and everyone in the game see it, the server can call a net multicast function that makes an explosion happen, and now all the clients in the game are going to see that explosion happen and the game is going to be synced up. Now this might currently be a little bit confusing because if you're the client, why do you need to tell the server to do stuff? We've kind of established that yeah, you might want to tell the server to shoot, but remember that the server is literally in control of the game. So if we want to modify someone's health, we need to tell the server to do it. We never do it ourselves. So if we're a client, we always tell the server to do something. So let's say in our game that we want the cupcake to be taken away if you press a certain key. Well, on my screen, I can take the cupcake away, no worries. But none of the other players in the game are going to see the cupcake get removed from my hand. The way we do it is we tell the server, I want to remove the cupcake from my hand. The server will then have a replicated variable, and when it updates, all the players will get that notification that the cupcake has been removed from my hand. So let me show you how you would implement something like this. Inside of the character, I'm going to add a variable and I'm going to call it hasCupcake. Now the server is in control of this variable, but I want everyone else in the game to know whether or not I have the cupcake, so I need to replicate this hasCupcake variable. And I want to do a rep notify, because when I change this data, I need to call the function to hide the cupcake. So let's go ahead and do a rep notify. This will automatically add the onRep function for me. You can see here that the cupcake is the static mesh one. So what I'm going to do is I'm going to take the static mesh one and I'm simply going to hide it. So if we set hidden in game to true, this will hide the cupcake. Okay, so let's do it so that when I press the X key on my keyboard, it hides the cupcake. So I'm just going to type in X and I'm going to find the X event for keyboard events. So when I press the X key, we're going to set the hasCupcake value to false to hide my cupcake. And I'll make the default value for this true, because by default we should have the cupcake. So when I press X, we are no longer going to have the cupcake. Okay, let's try it out and we'll see if it works. Okay, so you can see me in the game. I'm going to go ahead and press the X key on my keyboard, and you can see that literally nothing happened. And if you know a little bit about networking, you'll know exactly why this happens. Remember, the server is the authoritative game. It needs to control the data and then feed that back to all the clients. So we're going to do our first server RPC. When I press the X key, I need to tell the server to do this, and then the server is going to do it, and then it should call this function and it'll hide the cupcake. So how do we do a server event? I'll show you how to do this in C++ as well, but for now we're sticking a blueprint. I'm going to add a custom event, and I'm going to say hide cupcake. Then where it says replicates, we need to go to run on server, and we'll make it reliable. We're not going to worry too much about what that means for now. Just make sure that this event runs on the server. And so now what we're going to do is we're going to plug it in here. And when I press the X key, what I want to do is I want to tell the server to hide the cupcake. So all I have to do is call this event and it will automatically run it on the server. The server then sets this value, and everyone in the game is then going to call that notify function, which should hide the cupcake. Okay, I'm here on the client. I'm going to go ahead and press the X key, and as you can see, it hid the cupcake, and everyone's game is in sync. You can see that on their screen, the cupcake also disappeared. That is how you do gameplay. The client tells the server to change some value, the server changes the value, replicates that state back to all the clients in the game, and that's how you would generally create a networked feature. You might also be wondering why all the clients can see each other running around, and that is because the default character movement in Unreal is actually networked out of the box, so you don't have to do anything to get networked movement set up and going in your game. At this point, you should have a pretty good understanding of Unreal Engine networking, the very basics anyway. So from here on out, it's going to start to get a little bit more complex, but I'll try to keep things as simple as I can. So let's look at this hasCupcake variable. So we have a rep notify, which means when this value changes, I want to call this function and do some stuff. Okay, well, let's look at the replication condition under that. The replication condition kind of tells you how you should replicate this value, and this is an optimization, so we don't always need to replicate this value. There might be times where we actually don't want to replicate a value to all the players in the game, or maybe we just want to replicate it to some of the players in the game. Maybe this hasCupcake value only ever changes once, and if that's the case, then we can use initial only as an optimization. The game will still work perfectly, but it will only send this change once, and then it will stop replicating this hasCupcake variable. So replication conditions are a way to optimize your networking in your game, which is really important if you're trying to make like a battle royale game where you have maybe 50 players on one map. Okay, next up we're going to talk about something called a net multicast event. A net multicast event is so tempting from a beginner's point of view, and beginners fall into the trap of using this everywhere. You should not be using this very often. It is useful in some cases, but people definitely overdo it, and it can lead to a lot of bugs in your game if you use this incorrectly. So a tempting thing that you can do is on the server you can run a net multicast event, and what that does is it will hide the cupcake because it's an event that happens on all the clients, just like my rep notify. But there are differences, and we're going to talk about these differences soon. So let's add another event. I'm going to call this hide cupcake multicast. It doesn't really matter what we call it, but just make sure that it is a net multicast. And then what I'm going to do is I'm not going to do this notify thing anymore. I'm literally just going to say hide cupcake multicast. So on the client, I press X, I tell the server I want to hide the cupcake. The server then does this function, and when the server does this, everyone in the game is going to run this. So it's a little bit complicated to wrap your head around, but if we come to the hide cupcake multicast, you'll see exactly how this works. When I press X, the server is going to make everyone in the game do this. They're going to hide the cupcake. And look how easy this is. I press X and the cupcake is hidden for everyone in the game. This is so much easier, right? I don't have to worry about a variable and this on rep. This looks very tempting to do it this way instead, but you shouldn't always do it this way. Here are the problems. The multicast is only going to happen if you're in the game. So if someone joins the game in 10 minutes after I've done this, they're going to see my player holding the cupcake, and this is a problem. We also don't send network updates all the time. If you're on the other side of the map, I'm probably not going to send network updates to you. You can control this, it's an optimization. So if you're on the other side of the map and I do this multicast, you're not going to run this multicast if you're on the other side of the map because we're optimizing. And so if you run to the other side of the map, this function never got called, and on your screen it's going to look like you're still holding the cupcake, right? The games are going to get out of sync, and this is exactly what we're trying to avoid. So coming back to the old way of doing it, we tell the server to hide the cupcake, the server is going to change this variable, and then it calls an onRep function. This fixes the case if a player joins halfway through the game or 10 minutes after I've hid the cupcake, this function still gets called because the player is going to join the game. It is going to see that this value has been updated, and it's going to call this good as gold. So if you join 10 minutes after we hide the cupcake, it'll still work perfectly fine. If you're on the other side of the map and you run over to me, I will not be holding the cupcake. Everything will work as expected. So let me give you a better example of this, because Unreal provides an example of this in the content examples. So here's the first instance. We have this chest. It doesn't have any replication. So when I walk up to the chest on the server, you can see that the server is going to open the lid, but for everyone else in the game, we don't see the lid of the chest opening. Now, remember when I said if someone's on the other side of the map, they're not going to see what happens? Well, obviously I can't show you an example of that, but this ring, we're pretending that being outside of the ring means you're on the other side of the map. This is called relevancy. If you're too far away from something, you're not going to receive the network information about it. So let me show you an example of this. One of the clients is going to run up to the chest. We're using a net multicast function. So you can see the client and the server open the chest, but the people that were outside of that ring, they don't see the chest open at all. Even if they run up to the chest, they're not going to see it open, because remember, the net multicast only gets called if we were sending network information at the time. So if all the clients are standing inside of that ring, it's actually going to work fine, because they're all receiving network information, so the chest works just fine. So in this example, the next one, we use a rep notify instead of a net multicast. So this should fix our problem, right? Even if you're outside of this ring, or you join midway through the game, it should work just fine. Let's have a look. So you can see that the clients are on the other side of the map, they don't know anything about this chest. When I open it up, they don't get the update, but as soon as they go near the chest, once they walk to the other side of the map, boom, you can see the chest opens up and their game is updated. Obviously, they wouldn't see that happen because this circle is massive in a real game. The only reason we have the circle so small is so you can actually see this easily and visualize it. But there is one big problem still. Notice that when I walk into the circle, it still plays the coins bouncing into the air animation, and it shouldn't, because that happened ages ago, right? We were on the other side of the map. We just got to the other side and it's played that animation. We don't want that. We want the chest to just be open, right? Because it might have been open 10 minutes ago, so there's no point playing that animation. And so this brings us to the final solution. We actually use net multicast and rep notify together. The net multicast will play the effect, and the rep notify will just open the lid of the chest. So on one of my clients, I'm going to go ahead and open the chest. You can see for anyone that wasn't on the other side of the map, they saw the animation play, but this guy in the bottom left corner, he was outside of the circle, so he is not receiving network update. But notice, once he moves across the map, you can see the lid is now open. It doesn't play the animation, it just opens the lid. This is exactly what you want. You can see we use a chest open notify to actually open the lid of the chest, and then we call a multicast function which plays that gold FX, which just spawns some particles. So these are the core building blocks of replication. You should know these really well if you ever want to work on an online game in Unreal. You want to learn actor replication, learn variable replication really well as well, and then start to figure out the rep notify stuff, server RPCs and net multicast RPCs, and also client RPCs. All you need to know with client RPCs is that they're the exact opposite of the server ones. You have to call them on the server, and in doing so, it'll then call them on the client. Alright, so now I'm going to show you some of the C++, and the reason I'm showing you the C++ last is because the main thing is to understand how networking works. Really, this is just the code, this is just the implementation, but understanding the concepts is way more important. But let me show you how to replicate a variable in C++. So let's make a float variable, and I'm going to call this health. I made an actor called ghost actor. All you need to do to replicate a variable is put uProperty, and then inside of the brackets just put replicated. And that will replicate our health value. The last step is to implement a virtual function called get lifetime replicated props. And that function looks like this. Create an implementation of it, then call the super function, and now to replicate our health value, you just do rep lifetime a ghost actor health, and so that will replicate the health value of our ghost actor. The server still needs to change the health value for clients to see it. This will work exactly as you'd expect. You can also add underscore condition, and this will mean that you can specify replication conditions like the one that I talked about, initial only, back in the editor. So you can add conditions in there as well. To check if you're the server, you can just do if has authority. This is the exact same as the switch has authority that we talked about back in Blueprints. To make an onRep, you want to just do the function that you want to make rep, so I'll just call it onRep health. And all you need to do is replicated using and then onRep health. And so now we just implement our function, and I'm just going to do a log in here. I'm going to say log health equals, and then I'm just going to display the health that the player has. So if the server ever changes this health variable, it's going to call our onRep function, and all the clients in the game will be able to log the health value. So on begin play, if I'm the server, I'm just going to set the health equal to 50. And this will call the onRep, and the clients will see that the health is 50. Lastly, to do a server RPC, you just do ufunction server, and then make sure to add reliable as well. And that's how you do a server function. To do a client, it's just client, and to do a multicast, it is just net multicast. Remember that if you want to replicate a variable, you need to turn replication on for the actor. So I just go into the constructor, and if I want to make this actor replicate, I just do set replicates true, and that's all I have to do to get that working. One thing I missed is if you want to have an onRep function, you need to remember to mark it as a U function, otherwise Unreal Engine will not be able to find the function. If you're using the get lifetime replicated props function, you will also need to include the header file for all the networking code, and all that is net/unrealnetwork.h, and now you will be able to replicate variables. I'm going to drag my ghost actor into the level, and I'll just give him a static mesh, and I'll just select the ghost. Down here you can see my output log. If I go ahead and run a game with 4 players in it, you can see that all the clients in the game have logged out health 50. So you can see that our onRep is working. If you want the server and all the clients to call the onRep function, all you need to do is change the health value and then also call the function on the server itself as well. And now the server and all 3 clients will call the health function. Thank you for watching, guys. If you enjoyed this and want more, I can talk about networking for hours. There's so much more to talk about, and even in an hour, I'm sure I only covered like maybe 30% of everything there is to know. But these are the core basics. Like, these are the building blocks for making a networked game, and the rest is just optimization and stuff like that. So if you want to see more, leave a comment and maybe I'll do like a part 2 or something. But anyways, thank you very much for watching, and I'll see you in the next video.